Ever pondered why we haven't yet met any extraterrestrial life? Could there be a cosmic roadblock hindering civilizations from interstellar exploration? As we look up at the night sky, filled with countless stars and galaxies, it's hard not to wonder, are we alone in the universe? This enigma is the heart of the Fermi paradox, named after the physicist Enrico Fermi. The paradox presents a stark contradiction. On one hand, we have the sheer enormity of the cosmos, brimming with billions of stars, each potentially hosting planets teeming with life. Yet on the other hand, we have the deafening silence. Despite our best efforts, we've found no evidence of extraterrestrial civilizations, no interstellar messages, no alien artifacts, nothing. So what gives? Is there a cosmic law, a universal rule that prevents the rise of advanced civilizations capable of interstellar travel? Or have we simply not been looking in the right places or listening at the right frequencies? This is where the concept of the Great Filter comes in. The Great Filter theory, proposed by economist Robin Hanson in the mid-90s, offers a potential answer to the Fermi paradox. It posits that at some point in the evolutionary timeline of a civilization, there's a barrier or filter that is incredibly hard to cross. This filter could be anything from a catastrophic natural disaster, a self-inflicted apocalypse, or even a technological hurdle that proves insurmountable. So where is this great filter? Has humanity already passed it, or is it lurking somewhere in our future, waiting to put the brakes on our advances? These are the questions that keep astronomers, physicists, and philosophers awake at night. Questions that provoke a sense of existential dread, but also a spark of curiosity. After all, it's in our nature to probe the mysteries of the universe, to push the boundaries of our knowledge, and to seek answers to questions that seem unanswerable. This is where the Great Filter theory enters the cosmic stage. The Great Filter theory presents a chilling prospect, a barrier that prevents life from spreading across the cosmos. This theory, a haunting brainchild of economist Robin Hanson, is rooted in the Drake equation, a formula used to estimate the number of civilizations in our galaxy with which we might communicate. Let's take a step back. The Drake equation, proposed by astrophysicist Frank Drake in 1961, is a probabilistic argument used to estimate the number of active, communicative, extraterrestrial civilizations in the Milky Way galaxy. It takes into account factors like rate of star formation, fraction of those stars that have planets, and the number of planets that could potentially support life. The Great Filter theory takes this equation a notch higher. It proposes that somewhere in the vast complex process from lifeless matter to star-hopping civilizations, there's a wall so impenetrable that it prevents the vast majority of life from evolving beyond a certain point. This wall is what's referred to as the Great Filter. Now, what could this filter be? It could be anything from a cataclysmic asteroid impact to self-destruction through technological advancement. The theory suggests that there is a stage in the evolutionary process that is extremely unlikely or impossible for most life to surpass. Think of this as the universe's own survival of the fittest. Only in this case, the fittest doesn't just survive. It advances, evolves, and eventually becomes a civilization capable of interstellar communication. The Great Filter theory, therefore, presents a rather grim picture. It suggests that the reason we haven't made contact with extraterrestrial life is because they've likely hit this filter and didn't make it through. And if that's true, we humans need to be very, very cautious, because that means the filter is still ahead of us. The Great Filter theory, in essence, suggests a doomsday scenario that has been, or will be, faced by all civilizations. So where does this place us humans in the grand scheme of the universe? This question leads us to the three scenarios presented by the Great Filter theory. We're rare, we're first, or we're doomed. Let's delve into each one, shall we? First up, we're rare. This scenario suggests that life in the universe is an uncommon occurrence. Perhaps the conditions necessary for life are so precise, so delicately balanced, that they rarely come together in the vast cosmos. Maybe life does exist elsewhere, but it's so sparse that the chances of us ever crossing paths with it are slim to none. If this is the case, it could mean we're alone in the universe, or at least in our corner of it. Next, we're first. Now, this one is a bit more optimistic. It proposes that we're not necessarily alone, but rather, we're the pioneers. Life may be common in the universe, but we just happen to be the first to reach a high level of technological advancement. In this scenario, the Great Filter lies behind us, and we've successfully navigated it. We're the trailblazers, setting a path for others to follow. Finally, we're doomed. This is the most ominous of the three. It suggests that the Great Filter isn't behind us, but rather it's ahead of us. It's a hurdle we've yet to face, one that all advanced civilizations must confront, and so far none have survived. Maybe it's a technological disaster of our own making, a natural catastrophe, or something else entirely. We can only speculate. Each scenario carries its own set of intriguing and perhaps unsettling implications. Have we already crossed the Great Filter, or is it still looming in our future? Are we alone, or are we just the first? Or is our fate sealed, destined for destruction like all civilizations before us? The Great Filter theory presents us with a cosmic conundrum, one that challenges our understanding of our place in the universe. As we gaze into the stars, the question remains, have we passed the Great Filter, or is it looming in our future? Diving into the implications of the Great Filter theory for humanity is not for the faint-hearted. It's a topic that's as fascinating as it is terrifying. We're talking about the survival and the potential extinction of our species, after all. If the Great Filter is still ahead of us, that means we're yet to face an event so catastrophic that it could wipe out intelligent life. This could be anything from a global nuclear war to a cataclysmic climate change event, or even the self-destruction brought on by advanced artificial intelligence. The possibilities are as endless as they are chilling. On the other hand, if we've already passed the Great Filter, it means we've survived the most significant threats to our existence. The dinosaurs' extinction, the ice ages, the bubonic plague, these could all be considered as potential Great Filters that we've successfully navigated. But here's where things get tricky. If we've indeed passed the Great Filter, why haven't we encountered other intelligent civilizations out there in the cosmos? This is where the Fermi paradox comes into play, posing the question, where is everybody? There are several theories to explain this paradox. Perhaps other intelligent life forms are avoiding us. Maybe they're hiding, or they've perished, or they're just too different for us to recognize. We simply do not know. What we do know, though, is that our understanding of the universe is still in its infancy. There's so much more to learn, to discover, to explore. The Great Filter theory forces us to confront the fragility of our existence and challenges us to do everything within our power to ensure the survival of our species. It's a sobering reminder that we must take care of our planet and each other. The hope, of course, is that we have already passed the Great Filter and the universe is ours to explore. The Great Filter theory, while compelling, is not without its critics and skeptics. This intriguing hypothesis, just like any scientific theory, is subjected to rigorous debate and scrutiny. The ongoing discourse centers around the validity of the theory and its implications for our understanding of life in the universe. Some critics argue that the Great Filter theory is overly pessimistic, presuming that every civilization is doomed to self-destruction. They highlight that the theory is based on a series of assumptions that may not hold true. For instance, it assumes that life universally follows a similar path to humanity, evolving from simple organisms to complex intelligent beings. On the other hand, proponents of the theory argue that it provides a sensible explanation for the Fermi paradox, the seeming contradiction between high estimates of the probability of extraterrestrial life and the lack of evidence or contact with such civilizations. Alternative theories have also been proposed to explain the silence of the cosmos. One such theory is the zoo hypothesis, which suggests that we are intentionally being left alone by more advanced civilizations, akin to animals in a zoo. Another theory, the transcension hypothesis, posits that advanced civilizations invariably leave our universe, perhaps for the singularity of a black hole. The current state of research is dynamic and evolving. New discoveries about the extremities of life on our own planet and the growing catalog of exoplanets in the habitable zone around other stars are continually reshaping our understanding of where life could potentially exist. These developments, along with advancements in technology, are providing us with more tools to probe the universe and its mysteries. While the debate over the Great Filter theory and its alternatives is far from settled, one thing is clear. Our curiosity about our place in the universe persists. We yearn to know, are we alone? Are we the first, the last, or just another civilization in the cosmic drama of life? While we may not have all the answers yet, the search for extraterrestrial life and our place in the universe continues to captivate our collective curiosity.